Hi there, welcome back to Triplicate, and what's this? If I didn't already know, I wouldn't know either. Well, I will tell you. It is a yogurt maker. So, what you do is you take enough milk to go in that pot, you heat it up to 80 or 90 degrees centigrade to pasteurise it, sterilise it, then you let it cool down to 42 degrees C, I believe. You put it in there with some yoghurt, either from the previous batch or from a commercial batch, and you turn this thing on, and basically it keeps it at 42 degrees for however long you want. 10 hours, I believe. My wife usually uses it, and I've never used it myself, to be honest. And after 10 hours you have yogurt. Wonderful. Yes. Except that we had a batch that was a bit iffy, and then the next batch was just awful and straight down the sink. So Angela just put some tap water in and turned it on and left it running, and it was just getting hotter and hotter and hotter, and it got to 55 degrees, and she concluded it was faulty. So I said I will have a look at it, and anybody on YouTube who so wishes can come along with me and we can see what's in it. So, well, I downloaded the manual and had a look, and it's fairly easy to operate. Plug it in. Okay, C1, which is a standard program. We'll have C1, it tells us we're doing 42 degrees C, whether we like it or not. C2, you can set the temperature to what you want. And we can do 10 hours, so we set it to 8 hours, and if we press, there it is, and it'll try and keep the contents of here at 42 degrees C for 8 hours, except it isn't working. It's just getting hotter and hotter and hotter. So, as it is, it's defunct. So I reckon there's no harm in us tearing into it and see if we can find out what's the matter with it, and hopefully seeing if we can repair it. Okay, taking the pot out of it and having a look around, cannot see any means of getting in there. There's those two screws, that just seems to be a drain hole. Those two screws, where the cable clamp, well, we'll take them out anyway. So perhaps there are some screws under the fibre feet here. And I tell you, there's one thing that annoys me. We all have our little things that annoy us. It's the plastic film left on the display and the buttons. There you go. The control panel looks smarter, even if it doesn't work. Right, we've got to pick. We're going to try picking these things out of here. Oh yes. Oh yes. Whoops, made a mess of that. Right, we get these little screws out with an inappropriate screwdriver and probably chew them up. The long screwdriver also, I mean, you can see the end of it. I tip it just a fraction. Right, this can come off as well. Right, this should come up and slide out. Yep. Okay. Now the cable should go into there, and this might or might not come apart. doesn't seem very keen on doing so. Okay, just gave it a good yank and it came out. So that's already heard something rattling. Something's come out. Might be, of course, the cause of the problem. Let's put it on its side. There we go. Right. So that is the heater, and it's still warm from when we fired it up for a minute or two earlier on. And this that is the mains board, that's the power supply. Now can you see that? Of course you can't see that. So that board, I'm guessing, is the power supply, which we know works because it's heating up. Connector here, which hopefully I can take out. Just stuck in with glue, of course. A bit of chiseling. Actually, easiest thing to do would be to take these two screws out of here. Oh, to come out, of course, come on. That might not be the easiest thing to do. Is that undoing the screw or just chewing the head up? Moving. Oops, never mind. Alright, so this board should come out of here. Right, pull some more of the mains to lead through and get rid of the base. Over here. Right. Okay, so just a quick look at the power supply board. So this is where the mains comes in, and that's the output of the heater. And if you look over there, there's tracks across here. So this, I guess, is a triac or a thyristor, probably a triac, because this looks like mains because of the I don't know whether you can see the slots between the pins to make sure there's no shorts across. Okay. Well, we know the heater's working. It's getting warm, and I can feel it's warm. So it's the temperature sensor, which must be, I guess, this little guy here. Yeah, you can see there's a little red thing. There's a lead at each end. Is this diode? Is it just using a diode? I do not know. Right. Well, I would suspect, I really thought that might have fallen out of its mounting and be flopping loose, so it's not picking up the temperature, but it's still mounted, so we're sort of guessing there's something up with it. Unless the electronics up at the top here has gone faulty, so that's soldered up somewhere in there. Which is that some kind of high temperature wire. And that is a chip. There's a chip there. Which I will real quick see if I can see what it is. Okay, so that is a HT46R004, which is an 8-bit micro, basically, which is doing all the job of the whole thing, I'm guessing. So we suspect this temperature sensor is not well. So I'm going to pull the main board off and hope and I can get out the connections from the top. I'm also going to do, I think, take off this connector and this connector, so and then get rid of the mains wire and everything, and it'll just make life a little bit easier. Okay, plan B, that is stuck on with hot melt glue, so I decided to leave it and I took the heater connection and the mains connection off. So shall we see if we can get this board off and see if all the switches and what have you and so forth disintegrate and fall out. Find the big screwdriver. Right, all the screws are out. No, it don't seem to out. See, yeah, the switches are just you see that? They're just no. That's quite clever. There's the main case and there's a curved piece of plastic, so the end of that is actually quite flexible relative to the main case, even though it's connected to it. So what have we got here? Some tack switches. Yep. And a connector for the temperature sensor. Here we go. After a fight, we've got the connector off, and we should be able to probe into those two little contacts down there. Well, come on. And we get 107 kiloohms if it's a resistor. Shall we try it the other way around? And we get 107, well 108 kiloohms, so it's resistive. It's a thermistor and it would appear to be working. Right, okay, so I am going to stick my finger on it. I think that is doing what it's supposed to be doing. Okay, so these are the back of the connector to the temperature sensor, and this side, all this round here is ground, and this is the live side, as it were. So that's just a little smoothing capacitor. It goes round here, through here, so it's connected to that resistor there, and this, I'm guessing, goes round here to the power, so that's power, 5 volts. And then it goes round to, come on, there we go, that pin of the processor where it presumably is an analog in. So all the circuits connected up correctly, so what I think we need to do now is connect it all up again, power it up, and see what happens when it's actually working. Alright, we have it sort of wired back together, and I've wired across the heater a neon, which hopefully will work so we can see when the heater's on. And I have here a hairdryer which I'm going to point at the temperature sensor, so hopefully we should be able to make it turn off by warming the temperature sensor up. So, the usual mains all across the bench jobby. So let's turn it on. C1. I think we want to press that button. 42, good. Press that button again. 8 hours, doesn't matter. So it's on. Yeah, and the heater's definitely going. So let's turn this on, and it makes a hell of a racket, so I won't be able to talk over it. Okay, well it hasn't turned off, and I'm sure that must have been getting up to 42 degrees. Oh, the metal's too hot to touch. Okay, so try a slightly different approach. We'll turn it on. And it comes on. So hang on. A little neon has come on, and I've just turned it on. It should not be doing anything. It should not be doing anything till I tell it to start heating. So I think that may well be the problem. Something has happened to the power circuit, and the heater is just on all the time, whether the process is telling it to be on or not, which would explain our little problem. Okay, so I took a picture of the underside of the board, flipped the picture over. So this is what the board would look like if the board was transparent. It's a single-sided board, which makes life a little bit easier. And I've drawn all the components on now, and I'm just going to turn that into a more readable schematic, and we'll have a look and see if we can think what might be wrong with this. Okay, so here we are. I've actually drawn all the components in and the connections, but that's not easy to follow the way it's laid out like that. So I've drawn it out a bit better, not a lot but a bit. Fuse to protect the incoming varistor, to take out transients. These two, this resistor and capacitor, drop mains voltage down to a few volts to make our 5 volts out of, and come in here and here. They come in up there, there and there. So I mentioned that is positive to that. That diode conducts and it basically shorts it out, so stops a big voltage building up. And if the other way, if that is positive to that, the power can go round the circuit, back in through that diode and out, allowing the capacitors to charge up, and the Zener there just prevents this voltage getting too big. Now this bit I think is all working because the electronics work, it powers up and the buttons and the processor are happening. So the bit we're interested in is the bit that drives the heater. So this is just a connection back from the processor. I'll find out exactly where it goes, presumably a 5 volts. This is a triac, and there's just these two resistors, and the fuse live goes to one end of the heater, and the other end of the heater goes through the triac and to the neutral. So fairly straightforward. I'm thinking the only possible thing that could have failed is the triac, but we will check that we are getting appropriate voltages here. If we fire it up and warm the heat sensor up. So time to connect it all up again and somehow see if I can put a meter on this without applying mains to myself or anything delicate. Okay, so this board has mains all over it. Nothing sketchy about any of this. Right, so the end of that resistor is 0 volts. And if we look at the other end of that connector, we get, come on, 5 and a bit volts. So yeah, goes up and down with the display flashing, which we would expect. So let's look at this. So this should be at 5 volts. Come on. Which it is. And this should be at the same volts. So the gate is off on the triac, which it is, and that should be nearly at the same 5 volts, which it is. But the little light's on and the heater's running, so I strongly suspect that triac is no longer with us. So just for fun, let's see what happens if we get it to turn off. Okay, sussed it. So let's turn it on. Check our voltage. Yep, that's where we want it, 5 volts. So we go into C2, hit set, down to 25 and turn it on. Yep, and it goes down to 0, so it thinks it's going. I mean, it's on all the time. We know it's faulty, so we now put that up so the heat stays in the bottom there, and it will, after a bit, warm up to 25 and turn off. Okay, it's got there, it's turned off again, finally. So I think the control circuit's working, so we are going to assume at this point, I think, that it is the triac that has died. I mean, the rest of it's just 2 resistors, and if the logic's working from the processor, I'm assuming the resistors are good. So, okay, here we are. So that little trag is a Mac 97A8, and here's one on eBay, so I shall buy one of these off eBay, and I think I shall finish this video here and start a new video when it arrives. So for now, it's goodbye from Triplicate. Goodbye.